In this video, we'll take a look at notes on section 9.5 on how to solve a trigonometric equation. So we're going to use Desmos to help us solve by graphing, and then we'll also solve by hand. So to solve an equation or any equation by graphing, graph the equation in Desmos or on a graphing calculator as two functions. Let f of x equal the left side of the equation and g of x equal the right side of the equation. So we're going to graph trigonometric equations. So our first equation that we're going to graph is the sine of x is equal to negative 1/2. So in Desmos, we're going to let f of x equal the sine x, and we're going to let g of x equal negative 1/2. And then we're going to take a look and see where those two intersect. So the intersections are the places where the functions are equal to each other. So our example, we're going to solve the sine of x equals negative 1/2 on the interval from 0 to 2 pi, and we want exact values. So how do we get Desmos to get us exact values instead of decimal? So the secret is in using the window on the x-axis and express it in terms of pi, in terms of radians, and then your units that you're counting by in terms of radians. So let me go ahead and open Desmos, and we'll take a look and see how to graph. So I've got the graphing calculator open. Let me bring it over. So I'm going to graph f of x is equal to the sine x. That was the left-hand side of the equation. And then the right-hand side was g of x is equal to negative 1/2. So notice it graphs it on a window, and it has whole number values. That's nice. That shows where it intersects. But what you can use to zero in on what the part you want to look at is use the graph settings. The x-axis, we want to solve between 0 and 2 pi. So let's go ahead and limit the x-axis to 0. And if you type 2 pi, it turns it into a pi. The step is what do you want to count by? So pi over 4, pi divided by 4, will help label the axis similar to the way we label it when we graphed. The y-axis, make sure your graph fits. The sign, max and min are negative 1 and 1. So we don't need to go to 6. Let's go from negative 1 to 1. And then now you can take a look. We've got our sine of x function, and we've got negative 1/2 graphed. And if you click on the points, the intersection points, the x value shows you their solution. So that means what sine has what angles have a sine of negative 1/2? 7 pi over 6 does, and 11 pi over 6 from the graph. So the solutions, 7 pi over 6 and 11 pi over 6. So if you're solving this equation by hand, think about you've got sine of x is equal to negative 1/2. You're taking the inverse sine of negative 1/2 is equal to x. And we want our solutions between 0 and 2 pi. So you can use the unit circle. Let me open the unit circle. There we go. So on the unit circle, where is the sign negative 1/2? So the sign is the y-coordinate, and it's negative 1/2 here at 11 pi over 6, and it's also negative 1/2 at 7 pi over 6. So that's two different ways to think about it, is using Desmos to graph and then using your unit circle. All right, the next example, we're going to solve the equation 16 times the sine of t times the cosine t is equal to negative 12 times the sine of t on the interval between 0 and 2 pi. All right, so this is a more complicated equation. So we're going to type in the left-hand side of the equation is the function f of t is 16 sine t cosine t. The right-hand side of the equation is a different function, negative 12 sine t. We're going to graph on the interval from 0 to 2 pi, and then see where they intersect. So you can see I've got the Desmos graph already cut and pasted. So use what you did from 0 to 2 pi. I've got my domain on there. And then make sure that your window will graph. So you type in 16 sine x times the cosine. I'll just use x. You can use t. G of x is negative 12 times the sine of x. And then I want to make sure that my window fits. The amplitude, we've got 16 multiplied here, 12 here. So that tells me I have to be a lot wider than 1. So adjust your y-axis, maybe negative 20 to positive 20. That might be a little too much, but everything fits. So your x-axis, I still have 0 to 2 pi by counting pi over 4. And then click on all the places where your function intersects. And that will tell you your solutions. So notice I've got pi, and I've got a 0 over here, I think, too. 0 and a pi. This is the maximum. That's not a solution. So I only want the places where they 2 pi 0. Okay. And then I've copied and pasted that so you can see the solutions. So how do you solve these by hand? Okay, so I'll do one example. So to solve this by hand, we can't divide both sides by the sign. It's tempting, but the sine of t could be 0. So what we do instead is get everything on one side, 0 on the other, and factor. So we have 16 times the sine t cosine t plus 12 sine t is equal to 0. And then factor. So treat sine t, cosine t as variables, two separate variables. These have, let's see, 4 goes into both 16 and 12. Both terms have sine t. If I factor 4 sine t out of the first term, I'm left with 4 cosine t. And then plus 12 divided by 4 is 3. Sine divided by sine is 1. So then take each factor and set it equal to 0. 4 times the sine t equals 0. 4 cosine t plus 3 is equal to 0. And then solve. So I have two solutions. The sine of t is equal to 0. And cosine t is equal to negative 3/4. So what I want to do is find out the angle measures for t, where the sine is 0 and where the cosine is negative 3/4. So take the inverse of both sides. So the inverse of 0 is equal to t. So that says that'll give me the angles that have a sine of 0. Well, I know from the unit circle that sine is 0 is the y-coordinate is 0 at 0, and again over here at pi, and then back at 2 pi. So since I'm taking a look and I have my domain from 0 less than or equal to x less than 2 pi, so the two places where the sine is 0, the two angle measures, are at 0 and pi. So those are two of my answers. Then to find the angle measures where the cosine equals negative 3/4, take the inverse cosine of negative 3/4. And I just want to remind you on the unit circle, cosine is the x value, and x value of negative 3/4 has two angle measures that go with it. This one, and then if you rotate negative direction. Okay, so there are two cosines, two angle measures that have the same cosine. When you do inverse cosine on the calculator, it's going to give you one of those between 0 and pi, because that limits the domain on inverse, and then you have to take 2 pi minus that to get the other. So inverse cosine, I'll use, make sure you're in radians. I'll go ahead and use the Desmos calculator. just the scientific calculator. Make sure you're in radians, and I want the inverse cosine of, let me see what my value was here, inverse cosine of negative 3/4. So that's negative 0.75. And I get a value of 2.419. So that's where this first value comes from, the 2.419. And then think about the other value as rotating the negative direction. Then you're also going to take, for your other angle, 2 pi minus 2.419. And that's where your other measure, 3.864, comes from. So the other two values are 2.419 and 3.864. So solving by hand and then using Desmos to check.